Yeah, so everybody told me I was speaking too fast on the first talk, so I'm going to redo the talk and talk slowly this time. A different subject. Yes, me, you know who I am. I think I can skip this slide. It's a kind of a tale. We got two great tales by Shivani and Juliana, and this one is another one on security. Defensive security is about building wall, and you got a lot of cats that try to go to the wall. Because anything that you have left open or done in a hard enough style is going to end up in being exploited. Sometimes by the bad guy, sometimes even by the good guys. That's one of the examples of this second category. So, I would like to give a big shout out to the people at Let's Encrypt. Because when you start an initiative where 20% of the traffic is encrypted, and you end up on something that is complicated to change, something like 15 years later to 80%, you have just changed the world. And this was done by a team that is now just 30 people. This is just crazy. It's a little bit bigger for OISF, but not that bigger. And that really impressed me. And so that's really nice for the global security. Yes, privacy win, security zero. Now we don't see that much on the traffic. If it was not some people to do some work on TLS, on SuriCata, we will have been blind. So at the beginning of the rise of TLS SSL, we switched from full visibility to basically just have bytes on packets, counter on flow, because nothing else was available. So some corporations did use decryption devices, but another piece that was open was the TLS on-check analysis. So I think that Pierre Chifflier is going to be super happy to see this slide. He will feel like home, because he's the one who did contribute the initial support of TLS in SuriCata. So in the on-check, as you can see here in a Wireshark screenshot, you have a lot of information, but really a lot, because they need to negotiate between the client and the server. So as a result, you need to exchange data. So server hello is a little bit small because basically picking everything you want. So we have less information on the other side. So there was one thing is that we have lost something that was really interesting. It is the fact that in HTTP, you've got the HTTP user agent. Basically, you know, even if it's a declaration, you knew who was connecting to the service, which type of software. And we lost that with TLS. And hence, the three gentlemen from Salesforce with all the G and A initial did start the JA3 concept, which is a fingerprint technology you may have heard about. So it's a client identification algorithm invented by John Altos, Jeff Atkinson, and Josh Atkins, created around 2017. And it's using simply the fact that the client in TLS is sending a lot of information, so after that, the server can decide which encryption to use. So the building algorithm of JA3 is simple. You take the SSL version, which is just an integer. You take the cipher, the SSL extension, the elliptic curve format, and then one field has multiple value. You are just going to put a dash in between, and you've got your JA3. So it's simple, and it works, so which is even better, because as the client is just trying to do TLS, it's not going to change the TLS parameter depending on the server. just want to do TLS, you say, I'm able of doing that, let's try to get to some common ground. So it was working, it was really able to identify implementation. So JA3 was really successful for a few years. It was used in a lot of different tools. Oh, I just realized that I did not put Zik in the right column. It's not voluntary, I'm really sorry for them. But they have the JA3 implementation, sorry for them. But we have SuriCata, we have Shark, Arkime, almost everybody has a JA3 implementation. Or by sniffing the traffic, or by looking at the traffic, or by knowing, getting the information at the negotiation time. Like a TLS server can implement a JA3 to determine which type of client are connecting to it. So the JA3 was successful because it was allowing you to know that you have a Chrome or a Firefox connecting to your website, so you can give them some different advertisement. And also because it was to the browser and to the version of the browser in some cases. And for a lot of malware, where you just download something that is small, so it means that you cannot embed OpenSSL. And because of that, it was easy to identify some malware just based on the JA3 signature. And then we had some interesting use case that was the JA3 to agent. So some mapping database were available, sorry, it's not that dead, are available to do the mapping. And it had become the de facto standard for fingerprinting, and it has been used in a lot of different tools. So at Stamus, we have a feature that we name Host Insight, which is a fingerprinting technology for the host, where we collect all the information about one host, and we build an identity card where we have got a lot of information that we track, like the username we see, the host name we see from the network, the HTTP user agent, the TLS agent. And for the TLS agent, the implementation is the following. We got the, where was the following, sorry. We got JA3, and then we know it corresponds to an implementation, so it gives us an idea of what variation of TLS agent I've got on the system. And we were mapping in post-processing the JA3 to the name of a potential implementation. So it looks like this. And here you can see, for instance, here we got the host name, we got the username that did connect, and the TLS agent was the thing that we're currently interested in. So what we have seen at one point in time is that we had huge overflow in the table. So what we are doing inside of the implementation is that we limit the number of each dimension we are tracking to a fixed number. And we do a first in, first out if ever some new value are coming. So this way we are not creating gigantic entry in case of something strange happening. And then we realized that on production, we had one host by itself that was triggering 1,000 new JA3 per minute. It was like, what? So we check. No, it was not a proxy with 20,000 people behind, but could be kind of the same thing. It was something completely different. On all the JA3 we did collect, it was changing all the time. It was not like 100 coming back and rotating on 50. It was just crazy. So yeah, so it was basically breaking the system, getting some performance hit, and it was not making sense. So we did not change the code at all. The system was in production since super long, and the change did suddenly appear without any change on the monitoring infrastructure. So yeah, what could it be? So it can just be the client itself. Then we found out what it was. And in Chrome, they did decide that always sending the same message at every TLS connection was boring. So that to spice up a little bit the life of people around the world, we should randomize some of the data that we were sending in the hello message. Okay, so what did happen is that usually you set the extension of that is the third parameter in the same order. You've got your implementation, you're not going to try to do something fancy. It comes as it comes, you don't choose the order, you don't really care, but you send it. But the RFC stipulates that only the last one should be in a fixed place, and so you can theoretically randomize this change, and it's not supposed to be important. And the explanation from Google, I'm still trying to understand it today, is that the server should not act based on the order of the extension. Yeah, so they did decide that to avoid this problem that I don't think was existing, or they don't give any proof, you should randomize the extension list when sending the hello message. Okay, so this was completely breaking JA3 because what you have is that even after a lot of reading, the thing is that one single implementation has no millions of JA3 fingerprints. Because we have, if I remember something like potentially 15 extensions, and you can have any of the rotation of the permutation of the extension list that can reach that are valid value in the hello. So if you are trying to do a mapping of JA3 like we were doing in the previous slides, using this to identify agent, it's just a fail anymore because now you've got millions of different TLS agents seen on one single IP. So for that, it's completely dead. So establishing a policy based on the JA3 that can be seen on firewall or reverse proxy is something that is dead too. You cannot, for instance, block a JA3 because it's going to change all the time. Yes, and it's a good trick also for malware. All the protection that have been implemented using JA3, they cannot be easily go around by malware, because now Google give them the trick to not be detected by all the JA3 fingerprinting technology. Yeah, so why this failure? Because main thing is that JA3 did, in fact, use the usage and not the RFC. So the freedom that was available on the extension list has not been taken into account when defining JA3. And this, as a result, has been used by Google in their decision to randomize because it will still work properly after that. It was still RFC compliant. And to add on top of this, in a lot of cases in the development of protocol, you need to deal with the RFC, and then you need also to deal with the fact that servers are okay to deal with clients that are violating the RFC, because the most important to them is to answer to the client. So the RFC is not even the one that is defining the degree of freedom. You need even to take into account the implementation. So, yeah, so but at least the design should be resistant to variation in the RFC and to have something that stays in the scope of the RFC. So, yeah, that was the error they made on this. And then to fix that, they also came, John Althaus mostly came with JA4. So no, he did not find another guy, a fourth guy with the same initial. He was just by himself on just do JA3 plus 1 that became JA4. Yeah, so it came with JA4, a TLS fingerprint technology that is a bit different, but that is really interesting. So we have The first letter here is it TCP or is it quick? Then we have a version 1.2 for 102, 1.3 becomes 13. So we can now even read it, even if it looks like a hash, but we can now read information inside, which is an interesting point in GA4. SNI, D to domain or I to IP. So we got an information about the type of connection. Number of cipher suite, number of extension, first application layer protocol negotiation value. So I don't have a slide on this, but it's now available in the SuriCata log. And it's allow you to know what proposed algorithm has been sent by the client, and the server is going to, for example, the client is going to say, okay, I'm good to talk HTTP or HTTP2. And then the server is going to answer, let's talk HTTP2 or let's talk HTTP1. That's one of the common examples of ALPN. So here we got H2 because it means that the client did propose the HTTP2 as the first desired protocol for the inside communication. Then we have sorted thing. So the thing to fight randomization, you just sort integer in the correct order, and then you're good. So we did that on the cipher suite and on the extension to fix the problem. And then the signature algorithm, for that, it's in fixed order, so we don't really care. It's put like in the real order. So that's, what do we have? Yep, okay. So that's kind of interesting. We got a lot of information. We got a lot of information in GA4 because we've got the TCP, we got the quick, we got the TLS, and so that's really cool. Yeah, so GA4. So the fact that we put these different things in this order with this definition is attached to a license. So I'm not a lawyer, but when I've seen that, it made no sense to me. You can potentially try to patent it, which will not work in Europe. But attaching a license to let's have a common agreement on how we are going to put things to build something is kind of strange. And the thing is that we have also another list that is interesting of GA4 extension, like GA4S and some other one. And so we have extension for SSH, we got extension for some other one. And yes, they want people to buy the right to use the algorithm. So that kind of, because there is a license on it. Okay. Yes, also for me it's like putting a rubber duck in a vegetable soup. Yeah, so what did I do? Yes, okay. Oh yes, I did explain a bit in advance what was here. Yeah, we got information on the connection. This fixed the randomization issue, so that's a good thing. So does it really fingerprint a website? No, the website, a client? Not really, because if a client is connecting via SNI to an IP address, you will have two values because SNI is part of a GA4. If you connect via TLS or via Quick, you have two potential hits. So we got up to 2 to 8, depending on the usage, GA4 from one single implementation, depending on what it supports. So we cannot strictly do a mapping, but we have the capability to at least have just a fixed number and not billion of entries. So a big hello to Sasha, that was not able to come. I hope he's getting better, because he contribute the GA4 support in SuriCata, so it's available in master, and it has been backported to 707. And it had TLS GA4 keys that can be activated in the configuration by setting a GA4 fingerprint to yes, or auto if you have some GA4 signature if you don't want the logging. And you need to have extended logging at least to output the GA4. Yep, so the example output. We have this super nice old domain here, TLS 1.2, we got the JA3 and we got the GA4 that is available in the TLS object. A recent addition is available at ja4db.com, where we have, you can download a big JSON file that is containing a mapping for all the GA4 type, so not just GA4 but GA4 Plus. And it's community maintained, so it seems that you can send an email, register, and then you can push your own mapping to contribute to the mapping. Sorry. The file is currently something like 45 meg, so there is a few entries in it. I don't have the full exact count. Sorry for that. Yep. So yeah, GA3. Yeah, time to switch to GA4. Hopefully, SuriCata 7 has GA4, because if you try to pinpoint implementation with GS3, you may risk to have the problem with its randomization. The adoption seems to take place for GA4. Then we have GA4 Plus, the other algorithm. They are interesting, but the license is seriously an issue. So I don't even think if we can discuss it during the roadmap because of this limitation. And that's it. Thank you. Question?
Thank you, Eric. I have a lot of questions, actually. I would, I guess, start with the last point. I think one of the things that we want to try with the plugin API is to make it possible to have GA4 Plus as a plugin, so that you can insert it into SuriCata without SuriCata or an OISF having to worry about those license issues. I guess I'm going backwards. The other one was the database that you referenced. Have you tried turning that into a data set and then using that in SuriCata?
I forget that I was speaking at 11, so I did not get the time. I thought it was in the afternoon.
Okay.
But it was on my plan to do that, yes. Yes.
That would be really interesting.
I can even use data JSON to do the mapping and then enrich.
Yep. Could you go to the slide where you explained the GA4 hash? So right now we have an option in SuriCata to match on this whole string. I was wondering, would it make sense to expose the individual sections, like the A, B, and C? Because they essentially tell you a bit different information that could be separately interesting, perhaps. I haven't really studied this.
The LPN information is really interesting, but at least having something to see what protocol have been negotiated. Because in this case, you can pinpoint some new user of or some verb protocol that are not supposed to be seen in one network. That could be nice. So that's something that could be interesting. For the extension Cypher Suite, I don't really know if we should match on part of it. TLS or Quick, we can, I think, already do it. TLS SNI, we can check that it's present. So yeah, I would just say getting a keyword for LPN will be of use. For the rest, maybe somebody has a better idea in the room, but at least for me, I just see LPN to be super useful.
Thank you.
So in your last slide, you say JA3 is obsolete, but what about JA3 from server? Do server do randomization as well, or is it just clients?
No. For the GS3S, sorry, I should have put that in the slides. GS3S is not impacted because the server just say we're going to use this on this on this, so there is no randomization there.
Thanks.
Yeah.
JA3S is not visible in TLS 1.3, I think.
I don't remember.
A question for Victor, maybe. You mentioned the possibility of doing for JA4 Plus some kind of a plugin type support for that. Interested if you thought about what that means for rule writers and supporting like some kind of conditional condition for rule providers to provide rules that evaluate conditionally on having that module available.
It's jogging time for Juliana.
With a couple of versions ago in 7, we added the ability to have a rule be loaded dependent on the version of Suricata, but also on a number of features that the engine has enabled, like JA3 and 4, because they can be enabled in the configuration or disabled. So I would expect that a plugin would be able to register such a feature, as we call it, and that you would be able to use it in the rule language to make sure that the rule is only loaded if the plugin would be loaded. But this still needs to be implemented.
Okay. Thanks, everybody.